Let's see how we are going to find the maximum value of this function here. And this question is from the calculus textbook by James Stewart in the problem plus section. How are we going to do it? Well, the answer for that is we'll use the Cauchy-Schwarz inequality, and that's one thing that you should learn when you study factors. So I'm going to give you guys a quick introduction to Cauchy-Schwarz inequality, and I'll also give you guys a proof of it, and we will see how we can use this to find the maximum of that in a few lines. Here we go. First, we are going to consider two factors, and because we have 3 terms, so I want two factors, both of them with 3 components. I will just call them A and B. So A is A1, A2, A3, B is B1, B2, B3. And the key right here is that we'll consider the dot product of A and B. So if we do that, yes, we can use the usual definition, A1 times B1 plus A2 times B2 plus A3 times B3. Or there's another formula. This is also equal to the magnitude of A times the magnitude of B times cosine of the angle theta, and that is the angle between these two factors. And I do have a separate video showing you guys why this formula is true, and the idea is just use the law of cosines. You guys can go ahead and check that out. So how are we going to continue? The key is apply an absolute value. On the left hand side, we still have absolute value of A dot B, and then the absolute value of a product, it's a product of the absolute value. And because the magnitude is never negative, so I don't need the red absolute value around it, I'll just keep it like this. Same thing right here. And we do have to maintain the absolute value for cosine theta. Now to get an inequality, we focus on this right here. Because note that cosine theta is always in between of -1 and 1 when theta is a real number. If we apply an absolute value around it, we can say this is less than or equal to 1. True for all real number theta. So this right here is less than or equal to, this 2 right here stays the same, but we replace this with 1. And of course, we can also write this down. And this right here is pretty much the Cauchy-Schwarz inequality. And now let me give you guys the component form because it will be more useful for that later on. So on the left hand side, we have the absolute value A dot B. I will use the usual definition, which is A1 B1 plus A2 B2 plus A3 B3. And that will still be less than or equal to the magnitude of A. It's just a square root of each them square, and you add them up. So square root A1 squared plus A2 squared plus A3 squared, and we multiply by the magnitude of B, which is the same thing. Just do this. Okay, we don't really like to have square roots. Let's just go ahead and square both sides. And some detail right here, because with the absolute value, the left hand side is non-negative, so is the right hand side because of the square root and all that. So when we square both sides, we can still maintain the same inequality. And then when we square this expression, because the absolute value is never negative, we don't need that. We can just write parentheses, the inside, and then square. And that will be less than or equal to square root and square cancel. So just A1 squared plus A2 squared plus A3 squared. And we multiply that with B1 squared, B2 squared, and B3 squared. And that is pretty much the Cauchy-Schwarz inequality. However, we have to be extra careful. Because when we have this kind of less than or equal to inequality, we can only get a bound. If we want to find the maximum value of a function, we have to make sure that we get the equality. So let's think about it. Earlier, we end up with this inequality because of this inequality, which is this idea here. So, in order for me to get the equality, I will have to make sure that absolute value of cosine theta has to be equal to 1. That implies the angle theta has to be either 0 or pi. And of course, there are a lot more angles than that, but cosine 0 is 1, cosine pi is -1, which the absolute value is still 1. This right here tells you that these two factors are what? They are parallel, because the angle between them is either 0 or pi. If it's pi, they're just going to opposite directions, but they're still parallel. So, in order for us to reach this equality, we have to make sure that A and B are parallel, and putting the component form, I can say this happens if A1, A2, A3. Remember, when the two factors are parallel, one has to be a constant multiple of the other. So we can just write this being equal to some number k times B1, B2, and B3. So this is what we need to find the maximum value of that function. Now let's have a look. First, we need to consider two factors, and each of them should have 3 components. So I'm going to say let my factor A be equal, let's see, we have A times X plus B times Y plus C times 1. So the inside here kind of reminds you of the dot product, right? I'm just going to pick up the coefficients for my A. So A, B, and C. And then the other factor, I will just have X, Y, and 1. Okay, then by Cauchy-Schwarz, we get the following. Just do the dot product and square that, so we get ax plus by plus c times 1 squared. That's what we got from the left hand side earlier. This will be less than or equal to. Now, square each component and add them up. So a squared plus b squared plus c squared times, and you do the same thing right here. And now this is so nice, because this is exactly what we have on the top, and this is exactly what we have on the bottom. Moreover, this thing right here is always greater than 0, right? This is never negative, and plus 1 is always greater than 0. We can just divide both sides by this, so we can get this being on the top, divided by x squared plus y squared plus 1. And that's exactly our function. And we see that has to be less than or equal to this, which is a squared plus b squared plus c squared. So we're pretty much done. We know this right here is always going to be less than or equal to this expression here. Imagine if you have, let's say, 2, 3, and 5, then just work that out. So we'll have a nice formula. However, in order for us to get the maximum of f, we have to make sure that this function can actually achieve this value. So we have to pay attention to the equality here. And then just as we mentioned earlier, for the equality, we have to make sure that this factor is a constant multiple of that. In another word, they have to be parallel. So this factor has to be parallel than that. In another word, this factor is just a constant multiple of that. So for the equality, we will have to make sure that A, B, C is equal to some number k times x, y, and 1. And now, of course, we can just set the components equal each other. So A is equal to k times x, and then B is equal to k times y, and C is equal to just k times 1, which is k. And remember, our function is based on x and y, so our goal is to actually find out for what x and y will make this work. Well, we know k is equal to c. That's very nice. K is just equal to c. And based on this, we can see that x is equal to a over k, which is just a over c. Likewise, y is equal to b over k, and that's just b over c. So we can just come back here. This equality will achieve when x equals a over c and y equals b over c. So an example, if a is 2, b is 3, and c is 5, this function will achieve this maximum when we have 2 over 5 for x and then 3 over 5 for c. And you can compute it. That's it. So this right here is the maximum value, and it happens right here. And you're done. And now next you can try to use the Lagrange multiplier and let me know how it goes. Yeah, I think it's going to be much more difficult. But of course, the Lagrange multiplier is more general. Imagine if you also have, let's say, x squared inside here, then this method is not going to work out as nicely as this one. So this question is more like a setup question so that it works out nicely when you use this inequality to help you out. Yep, that's it.